We're going to start with a little joke here. What's this? Of course, it's water on Mars. Now, seriously, hopefully you've gone through some of the chapter readings, and hopefully you've looked at that article that I've listed in the unit summary. Make sure you look at that article online. It's very important. And hopefully you realize that the Earth is very special, not only because we live on it, but because it's really the Goldilocks planet. It's not too hot, not too cold. It's, well, you know the answer to that. And if we look at our nearest neighbors, Venus, a little sunward, and Mars, a little bit in the other direction, you notice that Earth could have gone horribly wrong if it were a different distance from the sun and if other factors hadn't come into play. One of the important things in determining what the climate of a planet will be is, of course, its distance from the sun. Venus, of course, would be hotter than Earth because it's nearer the sun. But we can't explain the hellish temperatures of Venus simply by its distance from the sun. Something else is going on there. It has what we call a runaway greenhouse effect. Remember to watch the video on the greenhouse effect. Now, Venus, if it didn't have that dense atmosphere of carbon dioxide, would still be incredibly hot, but not hot enough to melt lead. Now, why is Venus so hot? Because it lacks a lot of water. Water on Earth helps to regulate the amount of carbon dioxide in the atmosphere and therefore helps to regulate our climate. Conversely, if we look at Mars, Mars also has an atmosphere that's mostly carbon dioxide. There just isn't very much of it. The atmosphere of Mars is incredibly thin, so it cannot generate a greenhouse effect today. And that is why Mars is a lot colder. Really, all it's relying upon is its distance from the sun, which is 1.5 times the distance of the Earth from the sun. But if we look at the surface of Mars, we see that it is riddled with what looks like ancient riverbeds and perhaps ancient lake beds. And some people think perhaps even maybe an ancient ocean bed. So in order for Mars to have had liquid water in relatively large amounts in the past, it had to have been warmer, which means that its atmosphere had to have been denser. And if it had a denser atmosphere of mainly carbon dioxide, it could generate a greenhouse effect and therefore, despite its distance from the sun, be warm enough to have liquid water. So the question is not just where did Mars's water go, but where did Mars's atmosphere go? Why is Mars today a cold, dry desert with very thin atmosphere of carbon dioxide? Now, some of the carbon dioxide is frozen in the polar ice caps. The polar ice caps are a mixture of water ice and so-called dry ice, frozen carbon dioxide. So that's where some of the carbon dioxide and water are. And some of the water is frozen into the ground in what we might think of as permafrost, and the same thing with some of the frozen carbon dioxide as well. But because Mars is small, it has less gravity, and it probably lost some of the water and carbon dioxide into space. Another thing that's important to understand about Mars is that it's tilted like the Earth, about 25 degrees versus our 23.5. So Mars has seasons. But there's some evidence that Mars's tilt may have been vastly different in the past, which means that its seasons would have been vastly different, and so too would have been its climate. So the golden age of Mars appears to have gone by. And Venus never really had a golden age. Sorry, it was hot and then became hotter. And so the lesson from that is, what might happen to the Earth in the future?